The acceleration produced by this gravitational force is called acceleration due to gravity. This is the velocity of train with respect to ground. With respect to his point of view, this is the velocity of train. So this 9 plus 2 gives you 11. Gravitational constant is high at the poles and it is low at the equator. Hello everyone. I am Nishma Nanjama, Faculty of Physics in Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. Welcome back once again to Session 5 on Chapter 3, Motion in a Straight Line. So, in this session, we shall study what do you mean by motion under gravity. What do you mean by motion under gravity and what is relative velocity. So, to begin with, motion under gravity, it is nothing but freely falling body. Freely falling body or object. Motion under gravity is not a complex topic to understand. So, you are aware of what is gravity, gravitational force. So, it's not a very complex topic to analyze. The motion under gravity is nothing but the uniformly accelerated motion exhibited by the object. We have studied in the previous session of motion in straight line what is uniform accelerated motion. So, if you don't know what is uniform accelerated motion, please watch my previous session on motion in a straight line. So, motion under gravity is nothing but the study of uniformly accelerated motion that is exhibited by the body or object. You can see an image here. A boy standing on the top of the building or top of the tower, and this is your base, this is your ground, this is your earth. So, a boy is standing on top of the building and he is dropping a ball or an object. I have considered a ball in my example. So, a boy is dropping a ball down. So, initially it was in rest. Initially, an object is in rest. You drop the object, so the position is displaced. There is a displacement of the position. Displacement is nothing but change in the position. That is nothing but velocity. So, object is at rest. You drop down the object vertically downward. So, there is change in velocity. Change in velocity is what? It is acceleration. So, it is termed as acceleration. When the object moved down vertically down, you can see the arrow. The ball is moving down vertically and it reaches the ground. And there is a gravity. Earth's gravity is pulling the ball towards the base, towards downward. So, when the object is moving downward, the gravity is also acting towards the earth. So, object comes under the influence of gravity. So, object comes under the influence of gravity. So, the gravitational force pulls the object towards the earth. So, acceleration produced by this force, that is gravitational force, is called acceleration due to gravity. So, when a body is released from the height, it is the height, it is h. H is nothing but the height of the, from where the ball is dropped to the earth. H is the height. So, a body is released from the height, it travels vertically downward, the surface of the earth, towards the surface of the earth. This is due to force of gravitational attraction, that is due to earth's gravity This is due to force of gravitational attraction exerted on the body by the earth. So, when the object is falling from the top, it comes under the influence of earth's gravity. Earth's gravitational force pulls this object towards it. So, that's the meaning of first point. So, the acceleration, so when the object is at rest, now it is displaced from its position, there is a change in velocity. Change in velocity is termed as acceleration. So, this body which is uniformly accelerating comes under the influence of gravity. The uniformly accelerated body is pulled by Earth's gravity. So, the acceleration produced by this gravitational force is called acceleration due to gravity. A third point, a body is moving down along a straight line with constant acceleration under the influence of gravity is called free fall. So what is free fall? So a body is moving downward. A ball is moving downward. A ball is moving downward in a straight line. So when you drop the object from certain height, the ball or the object is moving in a straight line. It is not following a curved path. It is moving in a straight line. So in our previous session, in graphical methods, we learned if it's moving in a straight line, then it possesses uniform acceleration. So the ball has uniform acceleration because it's moving in a straight line. When a ball is acting downwards, it is in a straight line, which means it has a constant acceleration under the influence of gravity. The gravity is pulling the ball, which is moving with a constant acceleration towards the earth. That is what we call free fall. So acceleration is represented by g, small g. You all are aware of it. Acceleration is represented by small g, and it is a constant term. It is a gravitational constant which has a value 9.8 meter per second square, which has a constant value 9.8 meter per square. Its value of g, the constant, gravitational constant, is high at the poles and it is low at the equator. What do you mean by that? Consider this is your earth. This is your earth and this is the center point of the earth. And you know, this is your equator and this is your north pole and this is your south pole. So the gravitational constant g is maximum at poles. It is maximum at poles and it is minimum at equator. G is minimum at equator. So for a freely falling object, for a freely falling body, A is equal to plus g, and for a body thrown vertically upwards, A is minus g. What does this sign plus and minus indicates? What's the significance of the sign plus and minus? Why it is plus here and why it is minus here? So let us take an example. For a freely falling body, a ball is dropped from a tower or a building. So it is moving in this direction. Gravitation of the earth is pulling the object. So gravity is also moving in this direction. So the direction of ball is along the direction of gravity. So ball is also moving in downward. Gravity is also acting downward. That means A is equal to plus G. You have positive sign. If it, instead of dropping down, if this is the earth, if you throw the ball up, the vertically you're throwing the ball up, that means the ball is moving in this direction, but gravity is acting towards earth. Earth's gravity is trying to pull the ball. So earth's gravity, if you throw the ball to certain height, it will again come back to earth. That is because of the influence of earth's gravitation. So gravity is acting downward. So you can see the opposite movement. The ball is going up, see the arrow, and the gravity is trying to pull it down. So there is opposite direction. The motion is opposite. That is why A is equal to minus G when the body is thrown vertically upward. And you can see here the value is high at the poles. The value of G is high at poles. That means you have the value of G is equal to 9.83 meter per second square. So the value of G is low at equator. So the value of G is 9.78 meter per second square. So at poles it's high, its value is 9.83. The value of G is low at equators, its value is 9.78. So by taking the average, we say the gravitational constant value is 9.8 meter per second square. So this is the gravitational constant value. This is about motion under gravity. So when I have this pen, I am holding it at certain height. The top of the building, I'll drop down this pen. So initially it is at rest. When it drop down, there is change in velocity. Change in velocity is termed as acceleration. Change in velocity by time is nothing but acceleration, and the ball is moving in straight line. That means there is uniform acceleration possessed by this pen. Why the acceleration? It is moving towards down because it's constantly moving in a straight line towards Earth, because Earth's gravity is pulling the pen towards Earth. So, pen comes under the influence of Earth's gravity. We throw the ball vertically downward. The gravity is also acting towards downward. That means the directions are same. That means A is equal to plus G. If you throw the pen up, the motion is towards upside, but the gravity is towards downside. They are opposite in direction. That means A is negative. And in Earth, the acceleration due to gravity is maximum at the poles, minimum at the equator. That means it's low at equator, high at the poles, and these are the value at poles and this is the value at equator. When you take average, the mean, you get gravitational constant as 9.8 meter per second. This is the value of G. Acceleration is represented by small g. And also we know that the value of G on the surface, different places, it varies. That's why it's high at poles and low at equator. This is about, this image clearly tells you, gives you a picture about what you mean by freely falling object. Freely falling object. The ball is moving towards the Earth with the ball is at certain height h, capital H, that it is at the building, and when you drop the ball, though it moves with uniform acceleration. Uniform acceleration due to the influence gravity, gravitational forces pulling that ball towards the ground. So this is about the motion under gravity. So next you have motion under gravity. We studied the equations of motion in our session 3. In session 3, go back to my session 3 and check what are the equations of motion. For rectilinear motion is nothing but linear motion. In this chapter, we study motion in one dimension. That is why nothing but rectilinear means 1D, one dimensional motion. We studied what are the equations of motion, that is kinematic equations. We know it is 1, 2, 3. There are 3 equations of motion. V is equal to U plus AT. V is the velocity, U is the initial velocity, V is the final velocity, A is acceleration, T is time. Similarly, we have second equation to determine the distance, or S is nothing but the displacement. S is equal to UT. U means it is the initial velocity, T is time, half into acceleration into time square. Third, we have to calculate what is the velocity. If you want to calculate what is the velocity of object, we take this third equation of motion. Final velocity square is equal to initial velocity square plus 2 acceleration into S is your displacement. S is your displacement or distance. So this is the equation of motion in one dimension. The same equation of motion under gravity can be written as follows. So equation of motion under gravity, what happens? A is replaced by G and S is equal to height h. Height h. For a freely falling body, the equations of motion under gravity, acceleration is equal to G. We saw A is equal to plus G and A is equal to minus G. So A is equal to G. For a freely falling body means it's moving towards downward. We are not applying some force and we are throwing towards up. So for freely falling body, A is equal to plus G and distance is equal to height h. Height of the tower from where we are dropping the ball or the object. And similar equation, you are just replacing A with G and S with H. So this is the equation of motion under gravity. And for a freely falling body, when I say freely falling body, you have seen U is equal to 0. Initial velocity is equal to 0. Freely falling body. So if you take U is equal to 0 for freely falling body or object, U is equal to 0. On substitution, you will get V is equal to GT because U is 0 here. Again, S is replaced by H. H is equal to U is 0. So, entire term is 0. So, only half GT square is there. Again, v square is equal to u is equal to 0. Initial velocity is 0. So, v square is equal to 2gh. A is replaced by g and s is replaced by h, and u is equal to 0 for a freely falling body. So, this is the equation for rectilinear motion, that is for linear motions, and this is equation for motion under gravity. If in terms of gravity they ask you for equation of motion, then this is the equation of motion. For freely falling body, this is the equation of motion. So next you have derive an expression for final velocity and time of fall for freely falling body. So what is your work here? You should derive the expression, obtain expression for velocity and time for freely falling body. It is very important term, freely falling body. So expression for final velocity. Let us first calculate this and then come towards time. So expression for final velocity, I'll take the third equation of motion. I'll take the third equation of motion. That is, I'll consider this equation to calculate the velocity of the freely falling body. So we know here S is replaced by h, because when it is freely falling body, they are talking in terms of gravity. So my equations of motion, of linear motion, is changed to gravitational, under the influence of gravity. So that means S is replaced by h, and since it is freely falling body, u is equal to 0 and a is equal to plus g, because it's freely falling. I am not throwing it vertically upward. They are not in opposite direction. So a is equal to plus g. Substitute this in this equation. So I'll get, you have the equation v square is equal to u square plus 2as. So here S is replaced by h, a is replaced by plus g. So v square is equal to u is nothing but 0, this term. So 0 plus 2gh. So v square is equal to 0 plus 1 is nothing but 1 itself. 0 plus 2gh is 2gh. Take the square root to the RHS, so you'll get 2gh. So this is the final velocity equation. Equation of velocity. This is the final equation of velocity for freely falling object or body. Similarly, how will you calculate for expression for time of fall? Time of fall of freely falling object. So when in case of time, I will consider the second equation of linear motion, that is S is equal to ut plus half at square. When it comes to time, I take the displacement equation. I need to know distance. So I'll calculate S is equal to ut plus half at square, and we know when in terms of freely falling body means it's talking in terms of gravitation, equation of motion under gravity. So the equation of linear motion, I need to change it to equation of motion under gravity. So the condition is S is equal to h, u is equal to 0. For a freely falling body, the initial velocity u is equal to 0. U is your initial velocity and v is your final velocity. A is equal to plus g because it's freely falling from top to down. So A is equal to plus g. So on substitution in this equation, you will get S is equal to, you have ut plus half at square. That means S is replaced by h. When you talk in terms of gravity, freely falling object, S is equal to h. Since u is equal to 0, this entire term is 0. 0 plus half, a is replaced by plus g and t square. So h is equal to half, this is plus half g t square. I want what is t, time for fall. So what I'll do, I will shuffle the terms so that I'll get t square is equal to 2h. 2 in the denominator, it's in the division. So when it go to LHS, it will be multiplied. So 2h by, again g comes to the denominator. 2 in the denominator goes this LHS. So it will be 2h by When 2g comes this side, it will be the denominator. So when I take out the square root, 2h by g is equal to t. So this is the equation. So this is the equation of time for free fall. This is the equation of time for free fall. So very simple derivation how you obtain the final velocity and time. So this is the, I'll consider the third equation of linear motion for velocity and second equation of linear motion for calculating time. So this is how you do the derivation. So similarly, next you have a problem given from which you have to derive the expression. So distance traveled during nth second of the motion. Distance traveled during nth second, 1, 2, 3 up to nth second of the motion. So what he has given here is, consider a body, it's starting with the initial velocity u. So your initial velocity is u and moving along a straight line. It is moving along a straight line with uniform acceleration. Since it's moving in a straight line, or it's quite obvious, we tell it's moving with uniform acceleration. A, acceleration is a, and let s1 and s2 be the distance traveled by the body in n second and n minus 1 second. You have the S1 and S2 is the distance traveled by the body in n second and n1 second. So you can write S1 travels in n second and S2 travels in n minus 1 second. So S2 be the distance traveled by body in n second and n minus 1 second respectively. So if Sn is the distance traveled in the nth second of motion, then if Sn is the distance, S1 and S2 are the distance traveled by body in n and n minus 1 second. If Sn is the distance traveled by the body in the nth second of motion, then we can write Sn is equal to S1 minus S2. S1 minus S2. So how will you calculate? They have asked you to calculate distance traveled by nth second. So Sn is the distance traveled by the nth second. So I'll take Sn is equal to S1 minus S2. So if you minus both the distance, you will get the distance Sn for the nth second. So what is Sn? When you talk about displacement, I'll take the second equation of motion of linear motion. That is second equation. Which is that? Second equation is nothing but S is equal to ut plus half at square. Consider this equation 1, which is the second equation of linear motion. So if you substitute, S is nothing but Sn here, Sn is equal to ut. So what do you mean by ut here? S1 it is n second. So un plus half a n square minus S2. Similarly, how will you take S2 here? For S2, the time is n minus 1 second. So substitute t minus 1 in place of t. So u, what is t? N minus 1 plus half a n minus 1 square, because it is t square. So for the first equation S1, the time is n second. So in place of t here, I have substituted n, and in place of t here, I have substituted n square. Similarly, for the second object, the time is n minus 1 second. So I have taken n minus 1 and n minus 1 square in place of t here for S2. Now on further substitution, you'll get un plus half a n square minus, on multiplication it is un minus minus it is plus u. So when you multiply the minus sign inside, again you'll get minus plus is minus half a, and it will be minus half, what is a minus 1 whole square? You know the mathematical formula of a minus b whole square. It is a square plus b square minus 2ab. Minus 2ab. When you have n minus 1 whole square, it will be n minus 1 whole square. What is your value here? It is n square plus 1 square. This is your a and this is your b. N square plus 1 square minus 2ab. b, minus 2ab. So when you substitute that here, you have half into a, half into a into this term. This term value you got to know, it is n square plus 1 square minus 2n1. So you have half a into this. So you have a negative sign as well. So when you multiply half inside, you will get half a n square plus half a, and again when you multiply inside, you will get minus 2 get cancels, you will get a n. Your 2 and 2 get cancelled, so you will get a n. So this is your equation. So when you multiply inside, so what is the value you get? When you multiply, you have negative sign. So it will be minus a n square minus plus, again minus half a, again minus, it is plus a n. It is minus a n. See which all the terms that can be cancelled. Plus half a n square can be cancelled with minus half a n square, and you can also cancel plus un with minus un. So what are the terms that are remaining now? I cancel the plus with negative term and negative with plus term. So what is remaining? Sn is equal to u, again plus an minus half a is remaining. Why it is not half a square, ma'am? You can get this question because you have 1 square is there. 1 square here. 1 square is nothing but 1 itself. So when you multiply half a into 1, it is half a itself. That's why there is no half a square, because 1 square is nothing but 1. So you have half a here. I have written to remove this term. To remove this term, what I'll do? I'll take a by 2 out. So it will be u plus, I'll take a by 2 out. So I'll get 2n minus 1. So remove this term, I'll take a by 2 out. So I'll get a by 2, 2 minus 1 in the bracket. So this is the Sn. This is the distance travelled in the nth second of motion. This is the distance travelled by the body in the nth second of motion. I hope I are clear with this derivation. Everything is mentioned in the question. I have just written the expression as Sn is equal to S1 minus S2. And I'll take the second equation of linear motion, that is the displacement equation, that is the distance equation, because they are asked for the distance travelled. So S1, when this is the case, if I take this as S1, if I take two equations, that is S1 is equal to un plus half a n square. N is because t is equal to n for S1 and t is equal to n minus 1 for S2. So S1 travels in n second, S2 travels in n minus 1 second. That's why I have taken t is equal to n here, t is equal to minus n here. So half, it is ut, t is n plus half a t square, n square, minus, I'll take the square bracket for whole S2 terms. So it will be minus, inside the bracket u, t is n minus 1 for S2. So u n minus 1 plus half n minus 1 whole square. So when you further substitute, un plus half a n square be same, minus, multiply the terms inside. So it will be un minus un, minus is plus, u1 is u. So plus u plus this simplification part I have shown here. So n minus 1 is similar to a minus b whole square formula in mathematics. So a minus b whole square is a square plus b square minus 2ab. Similarly, I have n minus 1, that means n minus 1 whole square. N is your a and 1 is your b. So the formula will change to n square plus b square minus 2ab. 2ab, this is nothing but 2n. 2n, 1 is nothing but 2n itself, and 1 square is nothing but 1. 1 square is nothing but 1 itself. So you have half here, half a n minus 1 whole square. So when you multiply half to this n minus whole square, you get half a n square plus half a, 1 square is nothing but 1 itself, plus half a minus half a n. Half 2 and 2 get cancelled, so it will be 2. 2 and 2 get cancelled, so it will be a n. Negative sign remains as it is. So you have negative sign outside. So when you take negative of this entire equation, you'll get half a n square Again it is minus half an square, and minus plus minus, you have minus here. So minus plus is again minus, minus half a, and again minus, minus is plus, so plus an. So this is the term you get if you simplify this entire term. So after that, plus and minus get cancelled and plus and minus get cancelled. Remaining terms are u plus an minus half a. So I want to remove this term. So what I'll do, I'll take a by 2 common. So a by 2 if I take out, I'll get 2n minus 1 inside the bracket. U plus a by 2, 2n minus 1 is the equation for the distance travelled in the nth second of motion. So if you understand this simplification part, this rest is, it is easier. So next you have relative velocity. What do you mean by the term relative? Relative velocity. So it is the velocity of one object with respect to the other object. So you have two objects here. You have one object and two objects. So the velocity of one object with respect to other object means that you have two objects. So there is a comparison between the velocity. So there is a comparison, that is, but relatively you check what is the velocity. If there is two cars moving in a straight road, there are two cars moving in the straight road. If I ask you to find out the speed, if a single car is moving, it is difficult to tell which car is moving faster. So when there is another car moving parallel to car 1, you can tell which car is moving faster. So how we are telling the particular car is moving faster? Relative to other car which is moving near that. You are moving in a traffic, you are moving in a heavy traffic, there are 3 to 4 vehicles, A, B, C, D. So I want to know which of the car is moving faster now. So if a single car is moving, how will you tell which is moving faster? So you can tell which is moving faster when there is a relative object. So we describe the speed relative to the other car. So when there are 4 cars, A, B, C, D, you can tell car A is moving faster than car B. That is the relative comparison we are making. That is what we call relative velocity. Since we are talking about velocity, it is relative velocity. It's the velocity of one object with respect to the other object. So motion is always relative. So take the example of a train. Take the example of that train. So what you can understand when you see this image, a boy is moving inside the train is moving with 9 meters per second, and the boy is standing outside the ground, that is on the earth. So he is observing the moving train. So what is the speed of the train from their frame of reference? We have different frame of reference, train and ground. From their frame of reference, what is the speed of the train is what this example illustrates about. This example illustrates the concept of velocity, that is relative velocity. So in the previous sessions I have explained what is frame of reference means. So please go through that. So you have train. So this is velocity of train with respect to ground. TG is train with respect to ground. So VPT means velocity of passenger with respect to train, and you have ground here. So that is VPG. VPG means velocity of passenger with respect to ground is VPG. So how will you explain this now? So train is moving towards the right with a velocity 9 meters per second. So this is the velocity of train. It is moving with 9 meters per second. So there are the passengers in the train. So a boy is moving towards the moving train. He is moving towards the moving train inside the train with velocity 2 meters per second. So there are the many passengers are traveling in the train. So a person B, say a person passenger B get up and he starts to walk inside the moving train towards the right with velocity 2 meters per second. So a boy is standing in the ground just outside the train. So is standing on the earth, his frame of reference. So what will be the speed of the train from his point of reference is what we have to find out. So a train is moving with velocity 9. It is moving with velocity 9. So boy is moving with velocity 2 meters per second inside the moving train. So For the passengers inside the train, a person is just walking with velocity 2 meters per second. So, but for the boy outside the train, that is in the platform, in the ground, he feels that he can see a boy is walking and train is moving. So, this plus this will be the velocity of train according to observer on the ground. That is what I have written here. So, this is the velocity of the passenger with respect to train. So, this 2 plus this velocity of train. This is the velocity of train with respect to ground, with respect to his point of view. This is the velocity of train. So, this 9 plus 2 gives you 11. So, this 11 is the velocity of the overall train observed by the passenger on the ground. So, it is 11 meter per second. So, consider if you have two objects A and B with velocity say VA and VB. There are two objects A and B with velocity VA and VB respectively. If they are moving with same velocity in same direction, your relative velocity VR will be VA plus VB. This is the velocity of A with respect to B. So, it will be VA plus VB. If the same object A and B having velocity VA and VB are moving in opposite direction. A is moving towards B and B is also moving towards A. They are moving in opposite direction. That means your relative velocity VR will be VA minus VB. The relative velocity VR is equal to velocity of A with respect to B. This is velocity of A with respect to B. Similarly, they are moving in opposite direction. So, this will be the velocity of A with respect to B. This will be the velocity. The negative sign is because they are moving in opposite direction. They are moving in same direction. That's why I have plus VB here. So, this is cleanly explained by the train example that I have illustrated here, which will help you to understand the concept of relative velocity. So, in this train example, you can see three terminology. One is VTG, one is VPT, and last is VPG. So, what does this VPT, VPG and VTG means? This is the velocity of train with respect to ground. TG means velocity of train with respect to ground. So, what is that? Velocity of train with respect to ground. It is 9 meter per second. Positive is because it is moving towards right. It is moving in the same direction. The person is also moving towards the same direction along the motion of train. So, it is plus 9.0. So, what do you mean by VPT? This is the velocity of passenger. Which is the velocity of passenger with respect to train. So, what is the velocity of passenger? PT with respect to train. It is plus 2 meter per second. Then what is this VPG? This is the velocity of passenger with respect to ground. How he is observing the velocity. So, this is velocity of passenger with respect to ground. So, for him it will be velocity of boy moving, velocity of B moving in the train plus the velocity of the moving train. It will be 11 meter per second, plus 11 because they are moving in the same direction. So, 11 meter per second. So, you understood the concept of plus and minus here. Same direction it is positive, opposite direction it is negative. Since they are moving in the same direction, that is why it is plus 11 meter per second. That is what this image here signifies. So, this velocity plus this velocity is the velocity of the passenger observed by the observer in the earth from his point of reference. So, I hope the concept of relative velocity is clear for you all. So in today's session, we learned what is motion under gravity. So acceleration due to gravity is given by the alphabet symbol G, and it is high at the poles and it is low at equator, and we saw the value of at poles it is 9.83 meter per second square, and at the equator it is 9.78 meter per second square. When you take the average, the value of gravitation G, gravitational constant G, is 9.8 meter per second, which is used everywhere. And we got to know that when you throw the ball vertically upward, so gravity is acting down, the ball is acting upward, A is equal to minus G. If the ball is dropped, if there is a free falling of the ball, free falling of object, it's also moving vertically downward, and gravitation is also acting downward. They're in same direction, so A is equal to plus G. That's the significance of plus and minus. Next, we studied the equations of linear motion. There are three equations, and when you talk about equations under gravity, how that equation will change, will alter. A will be replaced by plus G, and S will be replaced by height, capital H. And when you talk freely falling body, initial velocity U is equal to 0. When you substitute, you will get the equation of motion under gravity, the three equations. Next, we solved a numerical where we have to find out the distance travelled for the nth second of time, distance travelled by body for nth second of motion. So Sn is equal to, we got the value. So after that numerical, we studied what do you mean by relative velocity. What is relative velocity? It is the velocity of one object with respect to other. Whenever you want to describe the velocity, speed or the motion of the object, motion is relative. With respect to another object, you can easily define what is the velocity of speed of other object. That is the meaning of relative comparison we do. So we saw the illustration of train example which explained the concept of relative velocity. How the observer on the earth is his frame of reference. So how the passenger in the train is his frame of reference. How passenger and observer on the ground measures the velocity from different frame of reference. We got to know for him the passenger velocity will be his velocity plus the train velocity, that is 11 meter per second. And also we discussed how we derive the expression for final velocity and time for freely falling object. For velocity, we consider the third equation of linear motion, and when we talk about time, we know to know displacement. So we took the displacement, second equation of linear motion, and we solved the derivation and we got to the final velocity and final time equations. So that's all for today's session, students. This is the end of motion in a straight line chapter. I hope all these sessions were very interesting. Next, I'll come up with a new chapter and with new session with new physics topic. So until then, see you all. Take care. Have a good day. Thank you.